Hello everyone. So today we'll be starting with the second problem of the TLE Eliminator sheet for 1300 rated problems. Today the question is the different number of ones. So what does the problem state? That we are given an array and we have few consecutive queries. And for all the few queries will be given with two integers L and R, and we have to find that is there any two indexes I and j in between L and R such that a of I and a of j are not equal. So now let's get into the example. Suppose we are given the array as a as 1, 2, 1, 1, and we have q, that is the number of queries, equals to 3. So okay, in the question, it is given that the array is one index. So we'll take it as one index for now. We'll convert it into zero indexing later on. So after this, what we have, the first query that we have is 1, comma 5. So the value of left is 1 and the value of right is 5. So we have to find, is there any two indexes? Are there any two indexes, I and j, that are between 1 and 5, inclusive of them, such that the values at a of I and values of a at j are not equal? So between 1 and 5, we can see that the value at 1 and 3 are not equal, and the values at 2 and 3 are also not equal. So we can have multiple such answers. We have to give any one of them for each query. And the second example, second query was between 1 and 3. So between 1 and 3, we can see that we have the values 1 and 3 itself, because at 1 we have 1 and at 3 we have 2. So these are the two different things. And now we'll take the third example, that is 1 comma 2. So we can see that between 1 and 2 there are no such indexes that have different values. So when we don't have any such indexes, what we do is we print -1 and -1. So to get an efficient approach, what we can think of is, suppose we take the array again 1 1 2 1 1, and the qth query states that the values of L and R. So what we can do is we can find for the element A of R, what is the rightmost left index. What does that mean? So suppose we are at index 1, 2, 3. If suppose we are at index 3, what is the rightmost left index that is not equals to the value of 2? That is the index of 2, right? So for suppose for r equals to 3, we'll have this value as 2. So what this essentially is doing is, for every index the we find the rightmost index, rightmost left index. So for doing that, we'll take the array again, 1 1, and we will create a DP, suppose to store all the indexes as that. So for the first value, we'll consider it as one indexing. So 1, 2, 3, 4, and 5. These are the values. So for the first index, we'll consider it as 0 because we are going out of bounds for the first index. So we'll keep it as 0. So for the second index again, what we can see is there are no such elements before 1 that is not equals to 1. So for that also we'll keep it as a 0. So now for this third index, the value is 2. We can see that the second index is of value 1 that is not equals to 2. So for the index 3, we'll have a value of 2. Similarly, for index 4, we will have a value of index 3. And for index 5, we will have a value of index 3. So now what we can do is, whenever we have the qth query L comma R, so we can just go and check if dp of R. So dp of R are these values. If dp of R is greater than or equals to L. So suppose we have the L value as 1 and R value as 5. So what happens is, so we see that dp of 5 is equals to 3 and 3 is greater than equals to 1. So at that time, we have an answer. we have an answer. So when we have an answer, we need to print the ith and jth indexes. So how can we get that? So for getting that, we can have R and dp of R as the ith and jth indices. I hope this is clear to you. And if this happens, then we have an answer. Else we don't have an answer. So we print -1, comma -1. So now the question comes is how can we create this DP array? So we have seen that. So the DP array will be initialized with the length of the given array, and so we'll have an empty array of length 5. Okay, and we will initialize the first index with the value 0 always because we cannot compare it with anything before that. So we'll start a for loop, and we will go from the second index to the nth index, and we will check if the current element is equals to the previous element. If this happens, then the dp of I is equals to dp of I minus 1. Why is this? Suppose we have a 1 and a 1 consecutively. So whatever this so the first one, whatever it has as the rightmost left index, this one should also have the same value. That's why we copy it over here. And if the values are different, so suppose 1 and 2. Okay, so we are checking for 1 and 2. So if that happens, is then 2 should contain the index of 1. That is, if I'm at I should have the index of I minus 1. So else dp of I is equals to I minus 1. So before going into the queries, we pre-compute a dp array. So we have pre-computed a dp array. Now, suppose we have q queries, right? So we'll have while q minus minus is greater than 0. So taking q queries, we'll take the inputs as L. That is, okay, we have taken the inputs L and R, suppose. Now what we have to do is we will check that int what is the maximum left you can go. The maximum, okay, not the maximum. You can say it as the minimum left that you have to go. So minimum left is equals to dp of the right element. Okay. So now whenever, as we saw, if min left is greater than equals to the given left, we have an answer. So we can print that time the values of r plus we give some space and we'll have our min left. We can print it in the reverse fashion also, but it does not matter as stated in the question. And here we don't have an answer. So when we don't have an answer, we directly print a -1 and a space and a -1. So this is how we can solve this question. So this was a pseudocode. I hope it's clear to you. Now we'll code it up. So now let's start with the coding. So initially we are given an integer n, that is the length of the array, and we are given with the array. So because it is one indexing, we would increase the length of the array by 1, and we'll start with the first index. We can also convert it into a zero index array, but this also works over here. So we'll take it as the input. And we have also been given, after taking the input of the array, we are given with the value of q. That is the number of queries we want to go into. Okay, so as we saw, we will be pre-computing an DP array. So let's take this DP array as the same length as the given array, that is n plus 1. Now, what we'll do is dp of 1 should be 0 as we saw in the pre-computation stage. And now we will start with the second index and we'll go till the last index. And every time, if the current element is equals to the previous element, that is I minus 1, what we'll do is dp of I minus 1 directly Else, if not that case, we'll have dp of I equals to the previous index itself. Now we get into the queries. So we have few queries. Each query is gives us two values. The first one is left and the second one is the right value. Now we can have the value of min left, that is the dp of the right value. And once we have that, so we check if the min left is greater than equals to the left, then we have an answer. So we would print r, the right value, plus the min left value. Else, we directly print two minus ones. So we'll directly be printing minus one, a space, and a minus one again. So I hope the code is clear. We will be submitting this code now. So we can see that the code is here, and once we submit it, it will be accepted. The site was a bit slow, so I could not show you. So thank you for joining in. If you have any comments, please feel free to drop them in the comment section. I'll be reading them soon.